Welcome to the 3D Pitoti Scientists Lab, a novel visualization facility for the collaborative analysis of prehistoric rock art. Its core components are two multi-user 3D displays, real-time rendering techniques for large 3D scanning data, and a suite of collaborative 3D interaction techniques. Archaeologists can analyze the 3D surface at high magnification in order to better understand the marks. Here, for example, we see investigation of whether two lines are natural or man-made. The power wall allows a really fully immersive view of the surface. One can zoom in such that one is like an ant walking across the landscape created by the Peck-Marks on the rock surface. This really lets us understand how things were put together on the rock surface by the creators. The 3D tabletop display allows us to get an overview of the entire data set. Here, the middle part of Velcomonica. The multi-touch 3D navigation techniques available allow us to move around the valley and to zoom into particular rocks. Here, we're moving to a particular image in the Fopi di Nadro rock art area. The virtual photography feature allows us to capture part of an image so that one user can take it away and look at it on their own or talk to a second person about it, whilst the overall display remains available to everybody. This allows for a richer interaction with the data. The images captured by the virtual camera are stored in a gallery and can be recalled so as to allow, for example, comparison between figures that are found in vastly different parts of the valley. Petroglyphs are often quite shallow and are best seen using oblique light. In the field, archaeologists do this with mirrors in daylight to redirect the sunlight's angle, or with torches at night. In the 3D Pitoti Scientists Lab, we can use a virtual torch to achieve the same results, but in a much more controlled, scientific, replicable manner. We can also illuminate the pure geometry of the rock art, having removed the surface texture, which contains possibly distracting colors. This allows for a very pure view of the surface. This large warrior figure, it's almost a metre tall, from Dos Sottolaiolo, can be quite difficult to see, and even more so, the superimpositions present are almost impossible to see without the added illumination. Here we create a depth map in order to better see what's going on the rock surface, so different depths of pecking show up as different colours. The virtual photo tool can be used to create a section through the surface of the rock, helping us to understand superimpositions by looking at, as it were, the hills and valleys created on the rock surface by the art. The segmentation masks identify areas of similar pecking style. This allows us to, for example, reconstruct the process by which the rock art was created. The virtual photo can also be used as a clipboard to move data between the tabletop display and the power wall. Here, we are taking the segmentation mask image, the Peck style analysis image, from one part of Rock 12 at Seradina, and taking those images and moving them up to the top of the rock, probably 10 meters away, so that we can make a direct comparison of the style of pecking between two different images. Thank you for watching this presentation of the 3D visualization technologies developed as part of the European Union-funded 7th Framework ICT project, 3D Pitoti. We look forward to developing further powerful digital tools that will be of use in archaeology.